Hello everyone. In this section 7.8, I'll be talking about the inverse matrix. So far we learned how to add and subtract matrices. The condition was what? The two matrices need to be of the same size. And then we learned about matrix multiplication. The condition to be able to multiply two matrices together is the number of columns for the previous matrix is going to be the same and the number of row for the second matrix. Okay? Now we talk about the last item. We kind of talk about what? Matrix division, but we don't call it this way because inverse matrix. Alright? The very first thing that we have to care about is the condition. For inverse matrix, we only do square matrix. Okay, so let me write this way: square matrix only. Square matrices only. Okay, so we can only find the inverse matrix for square matrices. Okay. So recall a number. You have number 5, right? The reciprocal of number 5, or the inverse of number 5, is 1/5. Is that right? And instead of writing 1/5 this way, we have another way of writing 1/5. We write this way: 5 to the negative 1. Okay, it's 1/5. Say 2 over 3. Reciprocal of 2 over 3 is 3 over 2, and we can write what? 2 over 3, everything raised to the negative 1 means what? We flip the fraction over. Okay, so when we're going to inherit that kind of notation, we bring it to a matrix. So if you have a matrix A, square matrix, of course, okay, then the inverse of matrix A will be denoted as A to the negative 1, means A inverse. Okay, and think of it's 2 over 3 right here. So you can think of 2 over 3 as 2 times 1/3, right? And that means 2 times 3 to the inverse. Okay, so this is not a legal way of writing. So I'll show you. Say matrix A over matrix B. We don't have matrix division, by the way. So instead of A divided by B, you have something like A times B inverse. But since matrix preserve order, so we have two ways, two cases: either A times B inverse or B inverse times A. It depends. Okay. So whatever on the left hand side, gonna have the number of columns gonna match up with whatever the matrix that you have on the right hand side. So for the inverse, you have either one of those two ways. Depends on how you multiply. Okay, but anyway, today we're gonna learn about how to find the inverse of a matrix. Okay, and like numbers, not all numbers gonna have an inverse. Right? Most numbers can have an inverse except for 1, 0. 0 doesn't have inverse, so 1 over 0 is undefined. Similarly, for matrix, not all matrices are going to have inverse. The matrix that got determinant equal to 0, then it doesn't have inverse. So if determinant of A is equal to 0, then A's inverse does not exist. Okay, so A will not have an inverse if A equals to 0. Now in terms of matrix, we're talking about what? Determinant of A equal to 0. Okay, otherwise A gonna have an inverse. Next question is how to find the inverse of a matrix. Okay, and by the way, what is so special? What is the property of the inverse? Like number, you have say I got number 5, right? You time 1 over 5, which is the inverse. So 5 times 5 inverse always equal to 1. Number divided by itself is equal to 1. Divide by itself is multiplied by its reciprocal, by inverse. Same thing with matrix. You got a matrix A, you times the inverse. Think of it as like A over A, okay? But it is illegal to say it this way. It's not right. So we say multiply by the inverse. And it's always equal to number 1. And 1 means the identity matrix. And we talked about this already. Identity matrix is a square matrix that got diagonal equal to all 1s and everything else is 0. Okay? And very special thing about multiply by the inverse is what you can write any order you like. A times A inverse or A inverse times A. It's also equal to 1. Okay? So that will give you a hint of how to check to see if a matrix is the inverse of the other. If you multiply one matrix to another one and give you the identity, then this matrix is called the inverse of the other. Okay, so you 5 times 1/5 equal to 1, so you say that 1/5 is the inverse of 5, and vice versa. Okay. Now let me give you the definition of inverse matrix. One definition. Let A be a square matrix. Say n by n, okay? N could be 1, 2, 3, 4, 5. So 2 by 2, 3 by 3, be a square matrix of size n by n. Okay. If there exists a matrix B, of course still n by n, such that you take A times B is equal to B times A equal to the matrix I, of course still n by n, right? Then we say that B is the inverse of A, and B is denoted by A to the -1. Okay, next question. How do we find the inverse of a matrix? So let me start with the simple one, which they have a very trivial case. A is a matrix of the size 1 by 1, say 5. So obviously A inverse is 1/5, right? Because 1/5 is the inverse of 5. Okay, so let's move on to a less trivial case. What if A is of the size 2 by 2? So if A is of the size 2 by 2, say in general, A, B, C, D. Okay? And you want to find A inverse, this is what you're going to do. First of all, you're going to calculate the determinant of A. And recall that we're going to calculate the determinant of a 2 by 2 matrix, major subtract the minor. So A times B minus B times C. Okay, that's the determinant of A. And inverse matrices of A is this. With the matrix A, what's it going to do? Interchange the position of A and D. So D is going to be up here, A is going to be down here. And then B and C, you keep in the same position, but you change the sign. So negative A up here and negative C down here. Everything going to multiply by 1 over determinant of A. Okay? This is a number, so scalar, time this matrix. One more time, interchange A and B, change the sign of B and C, multiply by 1 over determinant of A. You have inverse. Example. You have a matrix A equal to 2, 1, 0, 2. Alright? So determinant of A is 2 times 2 minus 1 times 0, which is equal to 4. 2 times 2 is 4, minus 0 is 4. Okay? Determinant of A is 4. So A inverse is calculated this way. So 1 over 4 in front. Okay? 1 over determinant of A is 1 over 4. Now, the numbers in here, well, 2 here, 2 here. Interchange to 2 here, 2 here. And 0, 1 in here. 0 negative is 0. 1 here becomes negative 1. Okay, I change the sign of the minor and then I interchange the numbers on the major diagonal. Okay, so if you want to simplify, you can multiply 1/4 into the terms. Inside you got what? 1/2, negative 1/4, 0, and then 1/2. Because 1/4 times 2 is 1/2. Okay. Now you found the inverse of a 2 by 2 matrix. Question. How do you know it's really the inverse? How do you check? Make sure it's the inverse. You can take A inverse times A, see what happened. Or A times A inverse. Let me do both. Okay? 2, 1, 0, 2. You times 1/2, negative 1/4, 0, 1/2. Okay, a 2 by 2 times a 2 by 2, you're going to have the matrix of the side 2 by 2. Let's do it 2 by 2. All right, 2 by 2. Row 1 times column 1. 2 times 1/2 is 1. 1 times 0 is 0. 1 plus 0 is 1. Yeah. Row 1 column 2. 2 times -140 is -1/2. Plus 1/2 is 0. Row 2 column 1. 0 times 1/2 is 0. 2 times 0 is 0. Row 2 column 2. 2 times -1/4 is -1/2. All right. Was that right? I'm sorry, row 2 column 2. 0 times -1/4 is 0, and 2 times 1/2 is 1. Oh, that's better. Okay. And similarly, you can try it the other way. Take the A inverse times A. I claim that you have the same answer. Oh, take that as a little homework for you to try it at home. Now, the next question is, what if I have a bigger size matrix? Instead of 2 by 2, what if I have a 3 by 3, or 4 by 4, or 5 by 5? How can I find the inverse? Nowadays we have calculator, and I honestly don't know what kind of calculator you have. But if you have a graphing calculator, very good calculator, decent calculator, just plug in the matrix and type, say, name it A, and type A inverse, hit enter, it gives you the inverse. But to me, that's considered cheating. So I'm going to show you how to find the inverse of a square matrix in general using just paper and pencil or marker and whiteboard. Okay, so the idea is this. You have a matrix A, square matrix, right? You want to find the inverse. You're going to write identity matrix of the same side next to it. And you guys are going to do some row operations. And you're going to change the first part into the identity. And the second half is going to be the matrix B. And guess what? B will be the inverse of A. Okay. One more time, you have a matrix A, square matrix. You're going to write the identity matrix right next to it on the right hand side. And you're going to do a bunch of row operations. You make the first half of the matrix become the identity. And the second half B is going to be the inverse of A. And let me give you an example to clarify what I'm just saying. Okay? So, erase this. I'm going to give you the matrix A. So how about 3 by 3? So, 2, 1, 0, 0, -1, 1, 1, 0, -1. Okay? This is my matrix A. And I want to find the inverse of A. Okay, this is what I'm going to do. A, I. Okay? So I'm going to write down here 2, 1, 0, 0, -1, 1, 0, I'm sorry. 1, 0, -1. Alright, and this is my matrix A. I'm going to write the identity matrix I right next to it on the right hand side. So 1, 0, 0, 0, 1, 0, and 0, 0, 1. And this is A, by the way, and this is I. You guys see that I have a matrix of the size 3 by 6, right? 3 by 6. 3 rows and 6 columns. The left hand side half is the matrix A. The right hand side half of the matrix is the I. Okay. And I'm going to do a bunch of row operations in here to make the first half, the matrix A becomes the identity. And whatever I got on the right hand side half is going to be the inverse of A. So let's do it. We practiced row operation already, so let's do it quick in here. First of all, I'm going to make that 1 become 0. So how do I do this? Multiply this by -2 after the first row. So -2, row 3 plus row 1, rewrite it as row 3. Okay, time the entire thing row 3 by -2 and add to row 1. Rewrite row 3. So I keep row 1 the same. 2, 1, 0, 1, 0, 0, 0, -1, 1, 0, 1, 0. Now row 3. -2 times 1 plus 2 is 0. -2 times 0 plus 1 is 1. -2 times -1 is 2 plus 0 is 2. And then -2 times 0 plus 1 is 1, 0, and -2. Okay. Next, I'm gonna make this number 1 right here become 0. Okay, and obviously I'm gonna do row 2 and row 3. So take row 2 plus row 3, add them up, rewrite row 3. Let's write down here. Row 2 plus row 3, then rewrite it as row 3. Okay, I'll make that number 1 right here become 0. So what do we have in here? 2, 1, 0, 1, 0, 0, 0, negative 1, 1, 0, 1, 0. And add row 2 to row 3. 0 here, 0 here, 3 here, 1 here, 1 here, and negative 2 there. Okay, we have this. And now we're going to take care of the upper triangle, okay? We make 0 for the lower triangle. We make the upper triangle 0. We got a 0 right here already. Awesome. We're going to make that 1 right here become 0. How? Time row 2 by negative 3, then add to row 3. We go this way. Negative 3, row 2, plus row 3, and then we write it as row 2. Because we want to make that number, this number 1 right here become 0. Okay? We've done that before. With row operation, remember something called the Gauss-Jordan's elimination. It's exactly what we're doing here. So we change row 2, right? We keep row 1 and row 3 the same. 2, 1, 0, 1, 0, 0, row 3 is 0, 0, 3, 1, 1, negative 2. Now we calculate row 2. Negative row 2, 3 row 2 plus row 3. So 0 here. Negative 3 row 2, negative 3 times negative 1 is 3, plus 0 is 3, and that's going to be 0 here. This is my 0, by the way. And then what? Negative 3 row 2 plus row 3 is going to be 1. Negative 3 plus 1 is negative 2, and then the last one is negative 2. Negative 3 times 0 plus 2. Okay. So we have 2, 0 right here. Next, we're going to make this number 1 right here become 0. And I'm running out of space, so let me erase my upper matrix right here. Okay, how do I make that number 1 right here become 0? I'll multiply the first row by negative 3. So I got negative 3 right here, add to row 2. Okay, so let's write up here. Negative 3, row 1 plus row 2, and then we write it as row 1. Okay, change this number to 0. Let's see what we got. Very smaller, so I have enough room to write. Negative 3, row 1 plus row 2, we write it as row 1. Way up here. Okay, negative 3 times 2 is negative 6, plus 0 is negative 6. It's 0. This is 0. Negative 3 plus 1 is negative 2. 0 plus negative 2 is negative 2. And then negative 2 again. Okay? And row 2 and row 3 the same. 0, 3, 0, 1, negative 2, negative 2. 0, 0, 3, 1, 1, negative 2. Okay. So we're almost done. Our first half of the 3 by 6, we got the lower triangle all 0, upper triangle all 0. All you have to do now is make the diagonal becomes all 1. And that is simple. Divide the first row by negative 6, second row by 3, the third row by 3, you'll get the answer. Okay? And I can do all 3 operations at once. Let's do it. Row 1 divided by negative 6, we write it as row 1. Row 2 divided by 3. Go down here. Row 2 divided by 3, we write it as row 2. Row 3 divided by 3 as well, we write it as row 3. So we have what? Divided by negative 6, I got 1, 0, 0, 1/3, 1/3, 1/3. And 0, 1, 0. 1/3, negative 2/3, negative 2/3, and then 0, 0, 1, 1/3, 1/3, negative 2/3. Okay? And I got the matrix B right here. It's going to be the inverse. So let me write it up here. A inverse is 1/3, 1/3, 1/3, 1/3, negative 2/3, negative 2/3, and 1/3, 1/3, and negative 2/3. Okay, that's going to be the inverse. And by the way, if you don't like fraction, you can write this way: 1/3 outside. Okay, and what you got inside will be nice numbers: 1, 1, 1, 1, negative 2, negative 2, 1, 1, negative 2. See? Looks nicer. Okay, either way. So I'll show you how to find the inverse of a square matrix in general. So the idea is what? You write your original matrix on the left, you put the identity on the right, and you do a bunch of row operations, and you make the left matrix become identity, and the right part of your big matrix will become the inverse. Okay. Next, I'm going to show you another way of solving for system of linear equation using the inverse matrix. Okay, so let's have an example. You have a system. Solve for x, y, and z. Okay, if I give you this, 2x plus y, say, equal to 4. Negative y plus z equal to 1. And then x minus z equal to negative 2. Alright? So I have a system of 3 linear equations with 3 unknowns, x, y, and z. And I want to solve for x, y, and z. Alright? Now, I'm going to convert that system of linear equation into matrix. But this time, it's going to be a little bit different than the augmented matrix that we learned before. Take a look at this one right here. Actually, I copied this. I use the matrix for it. Look, 2, 1, 0, right? 0, negative 1, 1, and 1, 0, negative 1 for x, y, and z. So if I call the matrix A equal to that one right here, and if I'm not going to rewrite it, A is right here, okay? If I call the matrix X, say XA equal to X, Y, Z, this is capital X, okay? And the matrix B is 4, 1, negative 2. And you see what? A times X is equal to B. Write small up here. A times X is equal to B. Let's check it out. What is A? 2, 1, 0. 0, negative 1, 1. 1, 0, negative 1. Okay? And what is X? X, Y, Z. And what is B? 4, 1, 2. And matrix A is of the size 3 by 3. Matrix X is 3 by 1, right? 3 rows, 3 columns for A. X is 3 rows and 1 column. So 3 by 3 times 3 by 1 is okay, good, and the answer is going to be 3 by 1. So the condition meets, we can multiply and see what it is in here. Row 1 times column 1, you got number 4, right? 2x plus y plus no z equal to 4, right? This is the first equation. Second equation is what? Row 2 column 1 right here is equal to 1. Check it out. No x minus y plus z equal to 1. Yeah? And then the last row is what? 1x, no y, negative z equal to 2. So really this matrix of multiplication represents the system of linear equation that you have right here. In other words, you convert a system of linear equation in terms of real numbers into a single equation in terms of matrix. So you got the matrix A times the matrix X equal to the matrix B. You know A already, this one right here. You know B already, 4, 1, 2. You don't know X. X is X, Y, Z, and your job is to solve for matrix X. If you know matrix X, you know X and Y and Z, which is going to give you the answer. And the idea of solving for this matrix, I need some room to write, so let me erase this part. It's very similar to solving for linear equation. I got A times X equal to B, right? And how do I solve for X? divide both sides by matrix A. That was the idea. But we don't have division in terms of matrix. So what can we do? We multiply by the inverse of A. Another way of dividing. But multiplication in terms of matrix have order, preserve order. So we have to keep the same order. And to cancel out the A, I have to multiply A inverse on the left hand side next to A. So A inverse times A times X is going to be the same thing as A inverse times B. Let's see what happened in here. On the left hand side of the equation, I multiply A inverse on the left. So on the right hand side of the equation, I also have to multiply A inverse on the left. And you know what happened when you take A times A inverse? This is the identity. Okay, identity is like number 1 times X equal to A inverse times B. Identity is 1 already, so just X equal to A inverse times B. Another word, you have a system of linear equation, you convert to a matrix equation. And all you have to do is calculate A inverse. You know A inverse already, you take A inverse times B, you will have the answer. Okay, so here. A inverse times B going to give you the answer, where B is the last column of your equations, and the A inverse, of course, we have to calculate it. If you know A, you calculate A inverse. And save time, I use the same A right here. I got the A inverse right there. Okay, now let's calculate X. X is what? A inverse times B, right? And A inverse is right here. Let me use this. 1/3, 1, 1, 1, 1, -2, -2, 1, 1, -2, and times B. Oh boy, what's a B? 4, 1, -2, if I remember it right. Yeah, we got the B. I'll multiply them. There's 1/3 in front, right? 1 times 4, 1 times 1, and 1 times -2. 1 times 4 is 4, plus 1 is 5, minus 2 is 3. Yeah. And then the second row, 1 times 4 is 4, minus 2, so minus 2, minus 4. So 4 right here, minus 2 plus 4, 4 plus 4 is, let me write down, 1 times 4 minus 2 plus 4. So what? A minus 2 is 6, yes. And then the last row right here, 1, 1, -2 times 4, 1, -2. So 1 times 4 is 4. 1 times 1 is 1. 1 plus 4 is 5. -2 times -2 is 4. 5 plus 4 is 9. And of course, you multiply by 1/3 in front, you got what? 1, 1, 2, and 3. And what does that mean? X is 1, Y is 2, and Z is 3. Okay? And this is another way of solving for system linear equation. So one more time, you have a system linear equation, you convert it into a matrix equation. A dot X equal to B, where X is the variable X, Y, Z. B is the left-hand side column after the equal sign, and A is the X, Y, Z column. Okay, it's going to be a square matrix. And multiply by the A inverse on both sides. So in a nutshell, we want to calculate, want to solve ABC. I'm sorry, solve X, Y, Z. You take A inverse on the left hand side times B on the right hand side. All you have to do is calculate A inverse, and then you have the answer. Okay, and this is the end of section 7.8. Thank you for watching. Any question, please ask. Have a good day, guys.